Key Concept 9, Target B. YouTube channel is Math Videos by Mr. A. Make sure to subscribe to the channel. Also turn on notifications. That way you're reminded every time a new video comes out. Enjoy. So Target 9B is more about analyzing and taking a look at what the graph of exponential functions look like. We'll start with the equation, the general equation for exponential functions, which is f of x equals a times b raised to x plus or minus c, and then plus or minus k. Okay. Keep in mind, b represents the base, the x plus c is the exponent, and then the plus or minus k is some value, some constant. Same thing with a. A represents some value, some constant in front of b. Alright, so example 1, we're trying to determine what the impact of k is. Okay, so this one right here. So you'll notice that I wrote 3 different equations, and we're going to sort of see what happens when we manipulate, when we change the value of k. Now in the first equation we have, it says graph f of x equals 2 raised to the x, and fill in the table with the correct values. Notice really there's no plus or minus k value there. Okay, so that's technically either plus or minus 0. And you'll notice that our graph, right here is the x-axis, right here is the y-axis. Going from left to right, you could tell that it's increasing. It's increasing exponentially, which means real quickly. The growth starts very slow at first over here, but once we make it to the right, all of a sudden you'll see that the graph shoots straight up. It almost looks like at some point it's going to go like a vertical line, but it will never actually be a vertical line. It'll always be going up and slightly to the right at the same time. It's just that it's increasing pretty fast. So the corresponding table values, as you can see here, there's x, -3 to +3. Here are the corresponding f of x values, also known as your y values. I chose these values just because the window, the graph, goes from 10 to -10. So they're the only ones that would actually fit on the graph that you can graph. And keep in mind, these are basically ordered pairs. So you have -3, 0.125, -2, 0.25. They're points that we can graph on the graph in order to see what the graph would look like of the exponential function. Now, we're altering the k value, so we're changing that. Notice for this, a was 0. Now for c, it's -3, and for b, it's +1. When it's +1, you'll notice that the graph went up a unit. Okay, so the blue one represents my original graph, 2 raised to the x. The red one represents my new graph, 2 raised to the x plus 1. Again, my graph moved up 1 unit. You can even see that in the values right here. Notice -3 before it was at 0.125. If we add 1 to that, we get 1.125. And all we did is we took all the y values and we added it by 1. Now, in the c value, -3, again, the blue one represents my original graph, 2 raised to the x. The red one was when we added 1, 2 raised to the x plus 1, which made the graph go up. Now it's -3, which made the graph go down 3 units. Okay, again, another example. If you look at -3, 0.125, you subtract 3 from 0.125 and you get -2.875. So basically move the graph up and down. So after example 1 ABC, there's a part where it says what is the impact of k. The impact of k is that it moves the graph up and down. So we say it shifts. Another way of saying move. It shifts the graph up and down. Notice when it was positive, it moved it up, but when it was negative, it shifted the graph downwards. So if we ever wanted to manipulate, if we ever wanted to make an exponential function, the graph of it move up and down, we would have to change the k value. Example 2, we're still looking at exponential functions in the graph of it. So again, as a reminder, This is the format of exponential functions. F of x equals a times b raised to the x plus or minus c, and then plus or minus k. But this time we're looking at what is the impact of c. So right up there. X obviously we're not going to mess around with because x will depend on whatever we decide to plug in for x. So we don't have much of a say for that right now. But c, what happens if we add or subtract something to the exponent? So again, looking at the original one, right here, we have f of x equals 2 raised to the x. Nothing is being added or subtracted to the exponent. So technically, the exponent is being added or subtracted by 0. However, you'll notice for b, we're going to subtract 2. And then for c, we're going to add 5. Now, the blue one in all the pictures represents the original graph, 2 raised to the x. In part B, the red one represents the new change. It represents the graph f of x equals 2 raised to x minus 2. So we subtracted 2 to the exponents. And notice how it changed from the blue graph to the red graph. It appears to have gone to the right. Okay, and then how much? 2 units. Okay, so looking at C, we added plus 5. So the blue one is the original one. The red one is the one that we just worked on. And the black one, the next one, is 2 raised to x plus 5. Now it actually went to the left 5 units. Okay, so when we add something to the exponent, it's going to shift our graph left to right horizontally, just like the x-axis. In the previous example we saw where we manipulated k made the graph go up or down, just like the y-axis. Right? But this time around, it's messing around with left to right movement. So after 2abc, for your observation, what's the impact of c? We'll go ahead and write down the impact of c is shifting the graph left to right. I know it's something a little bit interesting here. In the previous example, when we were messing around with k, when k was positive, it went up. Made sense. When k was negative, it went down. Made sense. Here it's a little bit of the opposite. When the c is positive, like in example c, it actually moved to the left. So positive c value will move it to the left, whereas a negative c value will move it to the right. Alright, so example 3, again, we're still looking at the same equation, f of x equals a times b raised to x plus or minus c, and then plus or minus k. But now we're looking at what is the impact of a. Okay, the first one, we have graph f of x equals 1 times 2 raised to the x. That's actually the graph that we've been looking at the beginning for all the graphs, or all the examples. The only thing is I made the one in front more obvious, but we really don't usually include it just because 2 raised to the x times the 1 is not going to change the graph in any way, but the 1 is there. Okay, now for b, you'll notice that a value, I then made it a 1/2, and then for c, I made the a value a 3. Okay, now looking at a, it's the original graph, 1 times 2 raised to the x. Our starting point was the ordered pair 0, 1. Okay, and we already know that if we think back to linear functions, when x was 0, that was our y-intercept. So it tells us where to start. Now if you look at b, that starting value is now 1/2. So you'll notice the red graph, instead of being at 0, 1, it's at 0, 1/2. So now our starting value is 1/2. We can then sort of make the prediction that it looks like a is changing where we start. And if we're correct, look at c. A is 3, so that tells me my graph should start at 3. And sure enough, it starts at 3. And my apologies, this table is actually incorrect right here. Give me a second, let me write down the correct one. I'm going to go ahead and write the correct table right here. X, Y. We'll still use the same x value, so we have -3, -2, -1, 0, 1, 2. and 3. When x is negative 3, y should have been 0.375. When x is negative 2, y should be 0.75. When x is negative 1, y should be 1.5. When x is 0, y should be 3. When x is 1, y should be 6. When x is 2, y should be 12. And then the last, when x is 3, y should be 24. Okay, so again, that table was incorrect. And the way I figured it out, because I told you A seems to be our starting point, and it was a 3 here. So sure enough, if you look at 0, 3, that's our starting point. So after the graph where it says what's your observation, the observation is going to be that the impact of A determines our starting point. So the impact of A is that it determines our starting point. And that's actually a pretty important observation. Granted, they're all pretty important, but even more so this one, because you think about it, when you're trying to graph something, you sort of want to know where you start with, especially if you're looking at real life problems. So the fact that A is where we start is pretty important. Keep in mind too, the function is f of x equals a times b raised to the exponent. So that value before the b, which you can sort of think of as a coefficient, I guess, is going to tell us where we start. All right, looking at example 4, again, still looking at f of x equals a times b raised to x plus or minus c, and then plus or minus k. But now, last thing we're going to sort of take a look at here is the impact of b. So we took a look at k first in example 1, and we determined that what k does is move the graph up and down. Then we looked at c, and we determined that c determines whether or not the graph goes left to right. In example 3, we looked at a, which we determined was our starting point. The last thing we're going to look at is b here. Okay, so for this one, I'm going to fill in the gaps a little bit just because there's an observation that I want you guys to notice, and it may not be obvious at first. A, we have f of x equals 2 raised to the x. That's the one we've been using this entire time. Okay. B is 2. So in this example, B is greater than 1. Okay. And what we ended up having was a graph that was increasing or growing. And it is an exponential graph. So we would say that this is exponential growth. Okay. Now, if you look at example B, B is 1/2. If you look at it from left to right, it's the red one. It's obviously not increasing anymore, it's decreasing, and it's exponential. So we don't call it exponential decrease, we call it exponential decay. Okay, now the condition on B is a little bit more specific. B has to be greater than 0, that's why the symbol is open towards B, but it has to be less than 1. Okay, notice B cannot be negative, so let me write that down somewhere too. B cannot be negative. Hold on, let me write that real quickly again. B can't be negative. It cannot be 0, and it cannot actually be 1 either. Those are special cases. You would have to graph them individually to see what they would look like, but B can't be negative, B cannot be 0, and B cannot be 1. Okay, that's where the not equal sign. However, if B is between 0 and 1, so like 0.25, 0.3, 0.01 even, that would be okay. And it could also be greater than 1. So it could be something as simple as 1.2. That's already greater than 1. So when we're looking at this, if B is greater than 1, you're going to have exponential growth. So your graph is going to be, from left to right, it's going to be going upwards. It's going to be increasing. If your B value is between 0 and 1, going from left to right, you're going to have a graph that's decreasing. So it's going to be exponential decay. So just to recap, K makes a graph go up and down, C makes a graph go left to right, A determines where your starting point is or your initial amount, and then B is going to determine whether you have exponential growth or you have exponential decay. Example 5a, write an exponential function that come out of the data in the table below. Okay, for this one, we're going to use the very basic format of an exponential function. So we have f of x, right? F of x lets us know that what we have is a function. We're going to have a, which we determined before was our initial amount, right? That was the whole point of looking at the graphs, times b, which we determined it's going to tell us whether it's growth or decay. So we'll just call that our growth. And then call it growth factor, I suppose. It'll determine if we have growth or decay. And then it's going to be raised to the x. So we're not going to worry the plus or minus c or the plus or minus k from the previous example. Now, your initial amount, remember, it's sort of like your y-intercept. So when x is 0, what's the y value? 1. So in this case, a equals 1. The next thing we need to determine is our growth factor. So is it increasing or decreasing? So for that, we're going to look at our output, our range, also known as our y values. We're going from 1 to 3 to 9 to 27 to 81. We're looking for it to multiply. Okay, so you gotta ask yourself, what would I need to multiply 1 by to get 3, 3 to get 9, 9 to get 27, 27 to get 81, and you'll figure out that you're multiplying by 3 each time. So our growth factor is multiplying by 3. Then we have enough to go ahead and plug it back in. So final answer will be f of x equals a, which we said was initial amount 1, times b, which is our growth factor, which is going to be 3 raised to the x. You can also write this down as f of x equals, I'm going to get rid of the 1 because no matter what 3 times x is, multiplying it by 1 won't change anything. So we can just write it as 3 raised to the x. So that would be our final answer. Example 5e, similar to what we just did, write an exponential function that come out of the data in the table below. Again, we're going for the most basic function, f of x equals a times b raised to the x. Okay. Now, a is your initial amount. When x is 0, what's y? Now, the only thing here is we can't determine that because in our graph, the x value 0 is not there. However, if you look at the x values, right, let's start there because we're looking for when x is 0. We're doing 1, 2, 3, 4, 5. So we know they're counting by 1. So if we go backwards, we should know that the x value 0 would be somewhere there. Now we just need to figure out what's the y value that goes with them. Okay, so let's figure out the pattern going downwards. How do we go from 1 to 2 to 4 to 8 to 16? You'll notice that we're multiplying by 2 each time. So if I wanted to go in reverse, I would need to take 1 and divide it by 2, which would give me 1/2. Or if you want to write it as a decimal, 0.50 or 0.5. So our original amount is going to be 0.5 or 1/2. They're equivalent. And then b is your growth factor. So in this case, we're multiplying by 2, so it'll just be 2. Okay, so we can write this as f of x equals a, if you want to do it as a decimal, 0.5, times, I'm going to do parentheses, times 2 raised to the x. Or I could write it as f of x equals a, will do the fraction 1/2 times 2 raised to the x. These are actually both the same exact answer. One just has a fraction, the other one is a decimal. They both mean the same exact thing. They're both equivalent.